So welcome everyone to the SUMOS 11th Tower Intermediate Sustainability Evaluation happening at 2020 Foiling Week Garda. So this is an online event we are doing this year for the known causes of the actual situation. So I will present my co-host Andrew Pindar to my left, will be supporting me, and who is also one of the supporters of the SUMA Challenge. And live we have the jury of the 11th Hour and Marine Shift, who are supporting the SUMA Challenge too, and Laura Marimon, aside from the three teams who presented their work so far from Milano, so Polini, Torino, Polito, and Rafal from ETS Montreal. Also, before I forget, who's to my right, it's Laura Marimon, who's one of the technical jury who is also joining us here in Garda. He came to give us a hand in the preparations, and she will maybe asking also some nice technical questions to the teams. So before further ado, I would like to introduce to the public what is the SUMA Challenge. SUMA stands for Sustainable Moth Competition. It's in partnership with the 11th Hour Racing and Marine Ships 360, who are promoting sustainability in different ways. Marine Ships 360 was developed by the 11th Hour, and it's a tool that all the teams are using to know what their LCA is. So, continue with that. What is it? It's basically a student competition. Any university can join. It's open worldwide. We have so far 8 teams that are joining from Canada, UK, USA, France, and 3 teams from Italy. Maybe later we're going to have some new teams from other countries that we have contacted. It's not confirmed yet. The boats need to be designed, manufactured, and sailed by students. Need to also comply with the international moth rules. We promote gender diversity, so the teams it's mandatory to have almost an equal amount of girls than the guys, and we encourage really strongly the 3R: reduce, reuse, and recycle. The ultimate goal of this competition is to inspire the yacht designers and manufacturers to go from a current full carbon moth that it's really efficient to something that it's as efficient by using different materials. This competition would not be possible with the support of the 11th Hour. And because of that, we have Jill Savory, who's the Sustainability Director from 11th Hour, Amy Munro, who is a Sustainability Officer, and also she was before in the development of Marine Shift 360, so she was there and helping us a lot during that period while playing with the software. And the third jury of this evaluation is Michel Marie, who is the LCA technical advisor and consultant for 11th Hour and Marine Shift 360. He was the one who, if I'm not mistaken, worked with Amy side to side to develop this software from scratch. Michel's CV is huge. Like, he has a lot of experience in both design, manufacturing, and sailing. He could talk about himself maybe later. It's quite interesting. The other person who will be helping today are Andrew Pindar. So I mentioned before, he's one of the supporters. I don't know if you want to introduce yourself a little bit.
Well, everybody else here is so young. I think that I've been invited along to bring the grey hair. But despite my grey hair and my advanced years, the subject that you're looking at is something that is dear to my heart. To see what we can do to make sure we don't completely trash the world that we live in. I'm the father of a 24-year-old and 22-year-old, so much the age of the students that have been contributing to this research and this study. When you get to the point of life that I'm at, and certainly in the reflection that we've been having over the last 6 months of lockdown and seeing the devastation on the world caused by a pandemic, I think that for me shows ever more the reason why we have to be looking at different ways of reinventing the world looking to see how we can just stop destroying the planet. So if you guys are part of that solution, then I, for one, am all ears. And I know that there are corporations who have been waking up to that type of thinking all over the world. So I'm excited to be here, and congratulations already for putting forward the great work that you've been doing. We're looking forward to seeing how that gets presented and the end results of that. So I'm an excited participant. I'm not sure I can help you too much, Bruno, but I might ask some old man stupid questions, but I hope you'll take them all the same.
Thank you for the intro. And actually, Andrew is helping us with the shipping of the Sumoth, and he's been working with SailGP and the Ocean Race into trying to make shipping much more sustainable. So that's what we're aiming, all of us together. The other person I would like to introduce herself is Laura.
Yeah, I will be one of the technical judges of the Sumoth Challenge, together with Bruno and Adriano, Mario, and Luca, and Chris. So yeah, we look forward to when the actual boat is going to be built to judge it and read the reports. And yeah, I'm very excited for this project, so keen to be in the loop.
Great, thank you. So actually, Laura is having a talk after this, and she does a lot of research at uni level, so she might help us putting together another Sumoth team for next year. We're actually crossing fingers. So we will start now with the videos that were submitted. So there from the three teams. We're going to start with Milano, following with Torino, and finishing with Rafale. After that, the teams will have time to defend their work. The jury will have time to ask questions about their work. So let's start with that.
Good day everyone, we are Politecnico di Milano sailing team, an old board team since 1734. No, not that old, but the team is active since 2007. We are constantly renewing, expanding membership toward all willing students, researchers and professors of Polimi family. We are now proud to welcome you to our Sustainable Moth Challenge project. We started by looking at what is the state of the art on moth construction, collecting literature and experiences. We deeply studied the field experience brought by us by the 2090s Polling Week, and in particular from our reference skipper Craig Assessa. From all this, we decided to develop our core ideas. We have available innovative and sustainable technologies, such as additive manufacturing, so the aim is to use them as much as possible to reduce waste of energy and materials. The relations we built with partner companies allow us to use low-impact materials, such as bioresins and basalt fiber. Our design is based on small footprint, in particular from a perspective of utilization of the parts. We take broken parts, we fix them, we test them, and then we use them in the new moth. We design parts and we want to produce them accordingly to reusability, meaning that they could fit future moth designs. This way, we extend the life of each component. Digitalization and data acquisition are nowadays the base of development. This improvement is pointing toward sustainability and safety. The Marine Shift 360 tool is acting for us like a compass. Together with the Sumoth Dollars counter tool we developed, it has affected our mindset and working methodologies. We use our time in a more productive way in order to use less resources. We shifted our focus on reducing the presence of high footprint elements such as molds and virgin materials. Each moth module will be able to fit future moth design. This way, we forecast multiple lives for each of them. The joining techniques are designed to perform accordingly. For this purpose, additive manufacturing will be used to produce small joining elements to be inserted where needed to meet modules' geometries. Additive manufacturing, along with a zero waste approach, will involve sustainable materials such as aluminum and PLA. Along with it, all moth modules must allow full disassembly for maintenance while in use, but focusing on our end-of-life sustainable disposal. Our moth will embrace innovative design solutions and manufacturing techniques, involving sustainable materials and extended end-of-life vision. It's all for now. We hope you the best. Stay safe, stay sailing.
Hi, I am Davide Sorli. I am member of the Polito team and manager of our Sumot project. In years of activity, the team has accumulated many materials from previous projects that lay unused in our warehouse. Our Sumot has the goal of exploiting as much as possible these materials that would otherwise remain unused. Where it was necessary, the use of new materials, we try to minimize the impact of our activities on the environment, orienting the choice towards more sustainable solutions, like the use of a bio-based epoxy resin, which our team uses at every stage of the construction process. We also tried to integrate used components into the design, so we choose to use used mast, boom and sail, saving a lot in terms of Sumot budget. To fully grasp the Sumot philosophy, we decided to also use materials that have reached the end of life. It was therefore decided to use broken windsurf masts to create the wings, characterizing element of the boat. In this way, an object intended to be thrown away is used to create a new fundamental component of the design. The choices made have allowed us to use many of our budget on the appendices, which is the most complicated element to design due to the important stresses they are subjected to, the fundamental role they have. The appendices must necessarily be made in carbon fiber and require a long manufacturing process, which takes many hours of CNC machining for the molds construction. Despite this, we decided to design our appendices rather than buying as at once, to seize the opportunity to increase our skills by studying an element we had never made before. For the end of life of our Sumot, we plan to recover all the fiber used in the hull and the deck using an innovative chemical process that we are developing. We also intend to recover carbon fiber used for appendices through already existing and well-known technological processes. The tool provided by Marine Shift 360 allowed us to compare different design solutions, choosing the way with the least impact on the environment. However, due to the design philosophy of our Sumot, which provides as far as possible the use of materials that we already own and that lay unused in the warehouse, mostly we have used the tool to compare possible solutions for minor elements of the design, such as the choice of material for the appendix molds, considering the more important parts of the project substantially closed. We have used the tool more to verify the impact of the project, verifying that molds are the element with the greatest weight, thus providing for the possibility of improving these parts in the future using less impacting processes and materials. We think that our design is the best precisely because of the philosophy behind our project. Therefore, the usage of unused materials in almost every element of the boat, and, where possible, the integration of upcycled components from broken objects, an approach that we think fully embraces the idea behind Sumot Challenge. We also believe we have created a great project, a boat capable of sailing efficiently and balanced in all conditions, capable of withstanding the characteristic stresses of a moth and strong enough to be used for many years. This was possible thanks to the skills the team has acquired in its years of skiff design experience and the great commitment and dedication to the project by all team members. We hope that COVID pandemic will end soon in order to allow us to finish the construction, so we hope to sail with our Sumot as soon as possible.
Hi, welcome in our workshop here in the ETS Montreal. I'm Pierre, I'm the co-captain of the Sumot Canadian team Rafale. I'm here today to talk about the sustainability of our project. Our main innovation is on the mold hold. We designed a symmetric mold that allows us to build the two parts of the boat in one single mold. Moreover, this mold has been machined in pine wood, that means it's totally recyclable. We also innovate on material. For the hull, we choose the basalt fiber, which is made with volcanic rock. We choose a PUT foam made with recycled PUT. And we choose for the resin, the Arkema helium resin, which is a resin that allows us to recycle all the boats at the end of the life. To reduce the amount of material used in the fabrication of the boats, we decided to make our foil by a CNC process. This stock of out-of-shelf-life prepared carbon that have been recycled from Rafale 2 will be used to machine our foils. With the technique, we don't have to make a plug or a mold. For the same reasons, our wing bar will be made by a folding aluminum tubes technique. Many elements used in the fabrication of Rafale 3 are upcycled or used. Those molds come from Rafale 2 and were used to fabricate the shaft of the catamarans. We will use them to fabricate our shaft for the Sumot. We will use out-of-shelf-life prepared carbon that also come from Rafale 2. We also recycle tax blocks and carbon tubes from Rafale 2. Our rigging and our sail were both used, and we also use lots of consumable items that from Rafale 1 and Rafale 2. Because there is no other moss in Canada and because none of us is able to sail a foiling boat for the moment, Rafale 3 will be used as long as it can float, as a training boat and as a reference for our future boats. At its end of life, the hull will be fully recycled because of the resin helium that allows us to recycle composites. It costs $7,000 Sumot to build the boat. We use marine shift to see which part or which phase of the boat pollute the most. It's the transport that pollutes the most because to go in Italy we have an emission of CO2 of 20 tons. That's 40 times more than the fabrication of all the boats. Two reasons why our project is amazing. The first one is that we develop a new process to build sailing dinghy boats with a symmetric mold. The second one is that we innovate on materials, especially in recycling composite materials. And the third one is that we have a huge capacity to upcycle and recycle elements from other projects. To conclude, the conception phase of the boat is finished, but we still have all the fabrication to do. The lockdown of the COVID just finished and the school reopened, so let's go back to work and make this boat.
So whenever you're ready,
Okay, I can go.
go ahead.
Okay, so good afternoon, everyone. We are Politecnico di Milano sailing team. And briefly here, we want to describe like our team and our design philosophy, the innovation that we inserted, and Sumot tolerance analysis, of course, along with the LCA analysis that we did. And then a little brief about what's next in our project. So the team is active since 2007, and now is subdivided in 5 sub-teams, each one focused on one specific aspect of the project. Regarding the design philosophy, we start for like the center of our experience, that is a sailor. Clelia Sessa is our reference sailor, and we brought as much experience as possible from her. In particular, we also analyzed the Foiling Week 2019 competitive mods, and in particular, we managed to weight some of them their components in order to find the center of gravity of the of the moth in order to create a model to study the critical, let's say, section of the moth itself, and along with then optimization for foils, hull, etc. Then with the design philosophy, we meant also advanced manufacturing, because in this way we go with, let's say, zero waste approach. In fact, advanced manufacturing focused mainly on this, like solving the conventional manufacturing problems. Along with, of course, the LCA and approach that force us to stay in a more sustainable condition. For materials, we analyze, of course, biocomposite and sustainable material. And in particular, we want to recycle, and we want to use recycled material and materials that have been already used, but can be used again. For design philosophy, we meant also the digitalization. That is something that is actually, let's say, missing from the naval industry. And in the digitalization, we would like to collect as much data as possible for future innovation and for data analysis of real, let's say, data from the experience that the sailor is feeling in the boat. So the innovation that we introduce are, of course, the waste reduction using advanced manufacturing, the fully recyclable molds, mainly for the hull, that will be in a fully recyclable material that will be collected by the providing company, and then it can be reused 100% fully. For digitalization, we implemented a system of sensors along in the boat itself, and it will be able to give us very, very important data along with what the sailor experience, and also the sailor will be able to see the data in real time. For the design, we thought each module as a separate one, in particular in a way that the modules can be used for future designs. In this way, we extend, in a way, the life of each module. And of course, the modules have to join between each other. But in this way, another advanced manufacturing process came along that is additive. And both in metal or polymeric material, it can be used in this way. Of course, additive manufacturing is a great advantage along with no waste, because the only waste that one could have is the support structure. But if the design is, let's say, pretty good, support structure are minimized. In fact, the selective laser melting is one of the main technology used for example, metal aluminum. And the idea is to use it both for structural component and also for non-structural one. Now, passing to the sum of dollar analysis, in a, let's say, in a rough way, the main issue are the manufacturing processes. And we have seen it like analyzing the overall budget that we are going to use, thanks to a tool that we developed for the sum of dollar. This tool, of course, takes the reference from the rule of the challenge. And as it is possible to see, the main causes of expenditure are the foils. This is due to the mold of the foils that has to be in metal, particular aluminum, and due to the manufacturing cost, this will affect a lot. Of course, the sum of dollar analysis takes account of the broken part that we consider in order to fix them and use them again, and the scrap that we're going to use, and the material that comes from a total recyclable way, so a circular approach. In this way, let's say the end of life of the components and the modules is extended, and the materials too. And also, of course, the waste is reduced as much as possible. A particular thing that we want to report is that our contribution in new material, meaning that the percentage of new material that we're going to insert in our moth consists of about 1/3 of the overall budget in sum of dollars, but actually it accounts only for 2% of the weight of the moth. And this is really important because it shows actually the important focus of the challenge. That's because we use only 2% in weight, but due to the rules of the challenge, it accounts a lot in our budget. And we thought that it's really, really important. I mean, it demonstrates that the challenge is really let's say, focus on what's really important. So sustainability and change the way to take new material over the recycled one, or etc. Regarding the Marine Shift 360 analysis, as it is possible to see for all the 5 indexes that came across over the dashboard, the hull, the terraces, and the foils are the main causes of let's say, increasing the indexes, and this is due to the production. In fact, in the data, we have seen that the use and the end of life of those specific components are not even sensibly comparable with the production of these kind of components. What's next for us? In particular, due to of course, to the pandemic, we needed to delay the design part, and we managed to, say, for the end of the year to finish overall, both the overall design phase and the foil designs. And for the beginning of the next year, start to manufacturing the final components, both for the hull and again for the sail and the foils. Then, starting from April, we go to, of course, assembly everything and test. And of course, thanks to sensors and, I mean, thanks to all the testing that we will perform, we will have a feedback at the correct and inevitably errors, let's say. So this is let's say, overall for us, but we are working even at distance, because here today we are in Polyme, but usually we meet thanks to a platform like Teams or Skype, but we managed to work in any case. I think that in any case, it is a really important, I mean, target for us, even if the situation is like that. So thank you very much for your attention. And I would like to take advantage to thank our partners that sponsor us for this competition and for the next year also. Thank you.
Well, thank you very much, Alessandro, for this great presentation. We're really happy with the work done so far. Actually, we see you put a lot of effort, and that's why we're here for, and to see the results. It's quite good for us. So I would let the jury take part now and start with some questions. So I don't know how you want to go through it. You can start with Jill.
Sure. My expertise is not in boat building, but I do have a question on your use of Marine Shift 360, the life cycle assessment tool that we are finishing development on now. Did you discover anything that changed your design or your processes by using Marine Shift 360 analysis, life cycle assessment analysis?
I mean, yes. It didn't change because we didn't manage to change it properly, but it makes us aware of the potentialities. I mean, in a way, for example, the energy that can be used for each specific advanced manufacturing process can be brought from renewable sources, and the tool is able to take advantage of it. But by the situation that we have here, for example, we are not able to take as much as wanted renewable sources, but this is only a case. Or I don't know, another big important aspect is packaging. Packaging affects a lot, both on the beginning when you have to purchase, but also when you have to move all the components from one point to another. And in fact, we change it. Basically, we skip from plastic to wood, for example. That is really, let's say, less impactful in some cases.
Amy or Michelle, do you have questions?
Yeah, very good presentation. I mean, very good work from everybody. But if we concentrate on your presentation, one question I have is, I mean, you speak a lot about data collection and putting a lot of sensors on the boat. Obviously, it's a very important aspect of any yacht design. But how do you see that as being important from a sustainability point of view? What do you see that as being positive?
Yeah, it's positive because we can optimize the component for sure. because in this way we can know, for example, the real wind on the terraces. For example, it's only an example, but it's a real data that is not so available as we have seen, I mean, from literature, but from our experience. And in this way, we can, let's say, launch some pretty detailed simulations, more accurate than the one that we have started hypothesizing the design now. Because, for example, now we started the design according to some hypotheses, and then we can feedback the hypotheses and, let's say, implement them in a new model. It's innovation.
Yeah, no,
And of course, from let's say, sorry to interrupt, but the sensors are, of course, reusable. They do not, let's say, last one year. They last a lot, and in this way, we can keep them and use them again whenever.
No, that's very good point. Thanks. I mean, it would be interesting in a full life cycle view of the project, see how much more energy you use by running all those side experiments. But
yeah.
I mean, something you can be captured in the tool. Probably is minimal, but there will be an impact associated to it.
Sure.
Thank you very much for that question. I think it was a good question from Michel. So nowadays we put a lot of electronics and stuff, and we don't know what to do afterwards. I see we all do the garbage bins full of electronics from old phones to old radios, and we don't think about it. So let's move. Yeah.
It's for sure that it will help you design a very advanced moth if you start putting a lot of sensors like that everywhere. Yes. So good luck for the optimization of the design.
Well, thank you.
Great. So let's continue with Amy.
I just have a quick one. It's more of a comment that I really like the modular design approach, and I was just wondering which kind of components or parts lend themselves best to that modular approach, whether they could be used again for other projects or other moths.
I'm sorry, but I didn't get the first part. I understood that you're talking about next moths, but I didn't get the first part. Sorry.
No, I was just saying I really like the modular design approach, and I was wondering which of those modular components best lend themselves to being reused and put in place on other moths in the future.
Yeah, the terraces first, and the hull. And in particular, for example, the joining element between the terraces and the hull can be easily performed by additive.
Nice, thank you.
Okay, great. The additive materials you're using are also biosourced, aside from
yes.
PLA?
Yes, yeah, PLA mainly for non-heavily structural components. In other cases, aluminum.
Okay, great. So before going to the more general questions, we will move on to Torino. I don't know if you have the presentation ready, Domenico.
Yeah, I have it. Good morning, everybody. I have to click on share screen. Yes. The audio. Maybe. Okay. And this is do you see it clearly?
Yes.
Okay. So my name is Domenico, and I'm a team member of Politoselling team. Hello, everybody. And this is the presentation for virtual SUMOT sustainability. We are a big team, as you can see. We are almost 80 people, or all engineers, designers, and architects. And we build boats. Facing the Falling SUMOT challenge, this new kind of rules and this new kind of philosophy, we had to change some of our belief and point of view. I mean, building a boat with the major aim in sustainability was pretty challenging, as I said, and kind of new. So because of this, we developed new ideas to face this new philosophy. And the most important were exploiting as much as possible materials that would otherwise remain unused, minimize the impact of our activities on the environment towards more sustainable solution, and integrate used components into the design. This was kind of new, and we really like it. The solution we found was the employment of an innovative and low environment impact fiber that we'll talk about it later. It's a basalt fiber, a special basalt fiber. For the appendages, we used the carbon fiber that we can't be recovered. We employed costless cores in small dollars, and we studied the moth, our moth, we designed our moth using components that will be reused or upcycled, and most important, we use a bio-based epoxy resin that has a part that is bio. The budget calculation in small dollars is as shown. We use it as a design tool to guide us in most of important choices, and for the fiber we used basalt fiber, and then it was costless in basalt in small dollars, a bit of glass, and most of the costs was for the machining, especially for the CNC that we'll see it later, and as you can see also for the sail and the rig. This is an important slide. In fact, shows most of our ideas to face the SMOT rules. In fact, we reused mast and sails from an older moth, Mach 2, and this was quite an idea just to face the SMOT rules, and we really liked it. But most importantly, to face the sustainability issues, we focused on the materials. It means that for the hull and deck, we use this basalt fiber that is recyclable, and we already used it for our previous project. So we already have it, and we are going to use it as a previous project XChess. As I said, the bio-based epoxy resin, and the core we use the PET that is already recycled from used bottles. Also, the appendage and foils comes from is a recyclable material, and it's a carbon fiber, and we already had it in our storage. And we are gonna use for the building of the rack. We are gonna use carbon windsurf masts that we will cut and build as we prefer. At the end of life of the moth, this is what was. It was really important for us, focusing on the end of life of our moth. Why? Because it was really challenging for us, and we achieved. We hope we will achieve a total recovery of the hull and decks basalt fiber through this innovative process that is under development. We are gonna recover the appendages carbon fiber through already existing and well-known technological process, and we come to reuse and upcycle all the remaining part of the components. The Marine Shift 360 helped us really a lot facing these issues, because it kind of built in us the awareness of what the production of the boat and on how is that important for the environment, and how it must be considered through the design process. In fact, most of the kilogram of CO2 emitted from our project is from the construction. Most of that is because of the CNC. In fact, we are, thanks to this, we are still trying to reduce even more this impact. And this is, as I said, as we can see, the structure for hull mold and the center board and the internal structure that are the one that are most where we use CNC and most complex processes. They are the most dangerous for the environment. So we are trying to develop them more. And that's all. Thanks for your attention.
So after this great presentation, thanks Domenico again. We will start again with the jury. I would say we can start with Amy this time.
Thanks very much for your presentation. That's really cool. I had a quick question around the appendages and foils being made. They're made out of scrap, sort of excess carbon fiber. Is that right?
Yeah.
Virgin carbon fiber. And I was just interested in, because you're saying sort of existing processes for recycling. What kind of processes are they? How is the fiber recycled, and how can you ensure that that the appendages follow that intended recycling route at their end of life, which may be a little bit of
it's
time down the line?
the simple pyrolysis of the resin with the carbon fiber. We have already contacted a lot of companies that deal with this, and they take carbon fiber composites and they burn it with pyrolysis, and then they build other objects with what remains with the remaining carbon fiber. And it's kind of a reuse of the material in our point of view, and different from the basalt fiber that it's another kind of process very where the fiber itself can be recycled and reused for building other composites.
Nice. And what would the lifespan of that part be, and how would you ensure that when that appendage comes to its end of life, that it definitely goes down that route, I guess, is the second part of the question.
Can you repeat the question, please?
So for example, if the lifespan of the part is maybe 2 or 3 years, maybe you're doing different projects, how can you ensure that the plan for the part that it's going to go to recycling at that particular place? How can you make sure that happens?
Because we will use to build other components with that carbon with the recycled carbon. The fact is that nowadays it's still not possible to achieve the same mechanical properties as before. So the idea was to use the recycled carbon fiber to maybe build non-structural components or sub-components that are not so stressed as the foils, the hydrofoils can be. So this is the idea for now.
Thank you.
You're welcome.
Thank you very much for that. So we can continue with Michel this time as the second questioner.
Hi, thanks for that very nice presentation. Nice project. I like the focus you have on the end of life. It's definitely an important aspect of life cycle. I mean, good point with the basal fiber, but I just wanted to know if you have, as part of the design exercise, if you have characterized the mechanical properties of the composite with basal fiber and integrated that into the design of your boat. So, I mean, basal fiber is not as strong as carbon fiber, so therefore you need a little bit more. Have you looked at all those aspects and mainly have you used the tool to quantify that?
Yeah. We've already done all the calculations and helping these issues that basal fiber is not so strong as carbon fiber. We have found a special basal fiber that has quite high mechanical properties and other interesting characteristics. And we've already used it, so we know how to manage it. And it would be ready, the boat, but we had the COVID problem. And so, yeah, we have done all the FEM calculus and CFD calculus. So, yeah, no problem with that.
And the other point is, I mean, PET core, yes, it's definitely a good core from a recycling point of view. But what we found on our project is that core does use a lot more resin than certain other cores, which might be having a higher footprint. But
yeah,
so have you done an exercise to take that into account and still end up with a better footprint than?
We noticed this. Okay. Did you think? Okay. We noticed this problem that the core absorb a lot of resin, but through some experimentation we have done in our laboratory, we noticed that if you maybe charge the resin with the small particles and then pass on and do a a thin layer before applying the core of the resin charged with particles, it will absorb really less. And we saw a great improvement. And I don't know if the guys in the building site will kill me because this was the kind of
No, it looks like you've got the problem under control. I mean, last question, and probably more for personal interest. I mean, basal fiber, yes, is sold as being 100% recyclable. It's been around for quite a few years now, but I haven't seen yet a full, let's say, commercial viable chain or supply chain for the waste. Is it progressing? Is it up and running, or is it still at the experimental stage?
It's still experimental stage. The results are quite assuring, and we wanted to do it. It was already. We were trying to pyrolyze it and then recover some particle of the basalt that would have gone inside the chain, and but the COVID stopped us again. And but we know people who has done this. This technology, unfortunately, is not already patented. It's not already patented, so they are really. They kind of keep their secrets, and also we have difficult to find documentation and academic articles about this thing. But fortunately, we found some serious proofs.
Thank you. Thanks.
You're welcome.
Thanks a lot for those nice explanations. I was wondering when you were giving away some of your internal techniques at this stage, but it's fine. It's good. You will have to do it anyways at the end.
They're good but building practices.
Yes.
Yeah, we
try to keep those a bit hidden for the moment.
And before we say goodbye, I'm really sorry about my English. I'm trying to improve it.
You're fine.
My accent.
You're not done yet. Like Jill is.
Yeah. We have another
really
question. Okay. Sorry, Jill. Hi, Jill.
I'll be quick. Mine are kind of just comments, and I think it's for all the teams. You've provided your Marine Shift 360 assessment on your plan, and I would be interested also to see that assessment versus business as usual, to see the improvements that you've made in your design, your use of recycled and upcycled materials. It's not for now to discuss, but that would be maybe for the next contest, we can have those submitted so we can see the reductions that you've made because of the choices you've made.
Yeah, it will be easy to prepare because we are already doing it, and we have a lot of things to say about Marine Shift 360 in the next.
Excellent. And I think it's just another comment. I think it's very fortunate that you have materials available to you to reuse and repurpose and upcycle. If you had not had access to like the windsurf mast and other component parts, what would you have done? Would you go searching for those materials? Because maybe not everybody has access. It's just a curiosity.
Yeah. For the fibers that we already had in our laboratory, it's because we are a team that built also skiff boats, so it was easy for us. For the mast of the windsurf, yeah, we went looking for them. So we went to all the people who we knew that had the windsurf and asked, hey, do you have some of, and they say yes. So for the fibers, I don't know, maybe we would have bought them because they are not easy to find. But for the rest, we really appreciated a lot the smart design concept and this kind of build your own boat, trying using everything you can find, everything you have access for.
Thank you.
Okay.
Welcome.
Thank you very much for these good presentations and questions. They're really good ones. So we'll continue with Rafal. Yeah, so there's a team from Montreal, Canada.
Yes, is everyone can hear me?
We have Pierre. Yes.
Yes.
Perfect.
So let's share my screen. Up. Okay, can you see my presentation?
Yes, I'm just adding it.
All right. So we are a team from Montreal in Canada. Our team was before designing and building a classic catamaran. So that's the first year for us to build a smaller boat and about thinking of ecological things, because before only performance was important. So here is our content. So our philosophy: reducing, reuse, recycle, innovate, end of life, progress. About the Summit project, the Marine Shift 360, the assessment, the team, and the sponsorship. So let's talk about our philosophy. It's to innovate, first of all, on the process and material, to reduce the amount of material needed to build a prototype, to upcycle elements from our previous projects, Rafale 1 and Rafale 2, to classic catamarans, and then to reuse as many as possible elements from other boat or other element. So to reduce the amount of material, the first thing is on the mold. So we designed a symmetric mold that allows us to build the two parts, starboard and the left part of the boat in port part in one single mold. So that's with this technique we don't have to build two molds. Only one is needed. We don't need a plug because this mold permit to make directly the two mold ports. The mold has been machined in pine wood, so it has less environmental impact than MDF, which is often used to make mold. It's like wood and resin. So this one is in pine wood. It can be fully recycled, and it will be reused for our next boats, or will be given to other team in Montreal, because maybe a team from McGill will have her own SUMOT team. So that's for the mold. So here is one of the ports of the boat, and the second one is just here. We just have a plug that's we put here and here to build the two different parts of the hull. So about the foils, we use prepreg carbon upcycled from Rafale 2, which is out of shelf life carbon, and we built with that a blank, and this blank will be machined to make our foils. So we don't make molds or plugs. We just use out of shelf life carbon and a CNC machine to build our boats. So that's a way to reduce the amount of material. And by the way, we also reduce out of shelf life material. So about the wing bars, we also decided to reduce the amount of material by using aluminum folding process. So we just fold the aluminum tubes. So with this technique, we also don't have to make molds or plugs. We just need some aluminum tubes and a CNC machine to fold the tubes. So now about reuse and upcycle. So we reuse and upcycle a lot of elements from our previous projects. For example, the shafts of Rafale 3 will be made with the mold of the shaft from Rafale 2. So here are the two molds of the shaft from Rafale 2. So we adapt the design of the shaft of Rafale 3 with the design of the rudder of Rafale 2, the catamaran. As I said, the foils were made with prepreg out of shelf life carbon that have been upcycled from Rafale 2. About all our consumables, they are reused from Rafale 2, such as the vacuum bag, the tape, the vacuum hose. Lot of elements are from Rafale 2. All the tacks, the blocks, and the pulley also come from excess or upcycled element from Rafale 1 and 2. We can see just over there is the hull of Rafale 1, and there is a lot of pulley on it, and we will take it to put it on the Rafale 3, so the SUMOT Rafale 3. About our tiller is made with carbon tubes upcycled from Rafale 2. The ladder trampoline is made with the trampoline of Rafale 1. And about the rigging, we bought it used at a French seller, because there is no moss in North America, especially in Canada. So it's difficult to us to find some elements of moss in North America. So now let's talk about innovation on materials. So as the poly team, we choose the basalt fiber to make our hull. At the beginning, we wanted to use the linen fiber, but this fiber was not competitive with the Arkema helium resin. And so for the resin, we use the Arkema helium resin, which is a thermoplastic infusible resin. So with this resin, we are able to recycle the composites. And for the core, we use PET recycled core. So the basalt fiber is woven like 15 kilometers away from our school, so where we make the boats. The core is make like 600 kilometers away, and the resin helium is given by a composite research center, which is like 40 kilometers away from the school. So just those projects are local projects. So about the end of life, we think about short term and long term. So about the hull, as I said, it will be used to build other prototypes, or will be given to another student club. And about long term, it will be recycled because it's 100% wood hull mold. And about the shaft, so the shafts are upcycled from Rafale 2, and when we have used it, we will given it to the new owner of Rafale 2, because the boat have been given to the skipper of the boat. And at the end of life, unfortunately, they will be buried under the ground because it's 100% carbon fiber and epoxy resin, so it's not recyclable at all. About the hull, the rigging, the aluminum parts, and the carbon parts, at short we use so. At short term, all the boats will be used as a training boat or a reference for our future prototypes because, as I said, there is no mouse in North America. So none of us is able to sail a foiling boat. So we will need a training boat and a boat of reference to make innovation on the next boat. So Rafale 3 will be used as long as it can float, I think. And at end of life, the parts that can be recycled will be recycled at the hull with the Arkema helium resin, and parts that couldn't be recycled will be just buried underground, unfortunately, as for carbon parts. Now, what's done, what's left? So the boat design is almost finished. We designed and built the hull, which is in our workshop. We received all the materials we needed to build all the parts of the boat, except from the tubing, aluminum tubing. I made the test composite material to build the hull. We had a lot of problems with the resin and with the release agents. We ordered and received the rigging from France like 2 weeks ago, and the mold is ready for the first infusion, and the foil stock had been made and will be machined in the October, I think. So what's left? A lot of things. Built each part of the boat. So everything in the fabrication parts and learning how to fly. About the Sumot dollar aspect, so here is the simplified budget. So if you want more information, I can show you the detailed one. So we are around 7,000 Sumot dollar for all the fabrication of the boat. As you can see in the origin and specification, a lot of material are used or upcycled from Rafale 2 or from other projects.
and that's it, I think. So if you have question, I can answer it at the end of the presentation. About the environmental impact, we use, as the other team, MarineShift. So I want just to tell you that those data not include the transport files, because there is like a bug in the MarineShift 360 simulation. So I will just talk about the transport just after.
Okay.
So for each part of the impact, it's the foils that have the biggest impact because of the prepreg carbon fiber. Even if it's out of shelf life, these elements are the worst for the environment. The hull have a small impact because of the wood, and I think the third part, which have the biggest impact, is the shafts. So we are around 600 kilogram of CO2 for the fabrication of the boats, which is not much. We can know that, for example, making a smartphone is around 1,000 kilogram of CO2. About the resource consumption, the huge part is at the production phase. About the energy consumption, it's the foils, which is have the worst impact because of the CNC machining of the prepreg. And for the water consumption is the hull, because of the wood, the pine wood mold. And then for the marine eutrophication, it's, as for the other parts, the foils because of the prepreg. So now let's talk about the transport. The transport is the worst phase of all the projects. So because we are in North America, we have to travel like 7,000 kilometers to go to Italy. This is 100 times more energy and 100 times more water consumption than all the fabrication of the boats. It's 40 times more CO2 emission than all the fabrication of the boats, and 38 times worse for the eutrophication of the oceans. So this is ridiculous how this transport phase have a bad impact on the environment. And those calculs have been made with just 5 members of the team that are traveled to Italy. So why our concept is amazing or the best, I don't know. Because we imagine, design and build a symmetric mold, which is allow us to reduce the amount of material needed to make a high performance boat. Our boats can be recycled because of the Arkema resin helium. We bought an innovative and eco-friendly boat because of innovation on material, and because we upcycle and reuse elements from other projects, and that's it. So this is the executive members of our team, and those are our sponsors. Thank you.
Thank you very much for this great presentation, Pierre. It's awesome. I cannot be really objective on Rafale since I was part of the team before, so I won't be asking any question, and I know the story. I will leave the good questions to Michel to begin with.
Hi, good to see you. Good to look at your presentation. Definitely a lot of work, a clear objective presented. It's good to see, and a very good use of the tool, which yes, sadly, transport is a huge impact, and especially air travel, as we know. But yeah, you've put some numbers to it, and it puts everything in perspective. Good choice of the resin for the end of life. It's not that easy to use that resin, but it creates some challenges, especially for the assembly of different parts. But yeah, it's a good choice. I mean, I've got a few questions. First of all, carbon and carbon fiber is recyclable. I mean, the process is now starting to be quite commercially viable. Maybe you don't have that availability in or in Canada, but definitely in North America, there is some centers where you can recycle the carbon. Something to bear in mind. I wonder if you have checked the impact of the aluminium for the tubing compared to if you were using carbon fiber tube. Is it
no, we don't compare it very much, but we just think about the amount of material needed. We just know that to make wing bars in carbon, we have to use a mold or a plug or the twice. So the amount of materials is bigger than if we just use aluminium and folding it. So that's just how we think on this part. We didn't compare really the different impacts on each material. We just think about the amount of material.
No, that's a good approach. You can't go wrong with that one. And the out-of-life carbon, I mean, did you relife it with the supplier, or did you check its mechanical properties? I mean, on a Sumoth, I think even if the thing breaks, nobody's going to be killed, but for sure, using out-of-life prepreg is a good outcome in terms of reuse and upcycling, but sometimes it's important to requalify the material to be sure that it's still.
So this prepreg was used to build Rafale 2, and it has been given by Bombardier, the aeronautic company, and we built some small tests to just see if the resin stick well, and it worked. So we just admit that it was okay, and built our blank to make the foils.
Okay.
But we don't do a mechanical test properly. We just make some small tests and admit that the resin was okay. So
yeah, I mean,
the parts.
It's a good start. If the resin behave normally, it's a good sign that it's going to do what it's supposed to do. Thank you.
Great.
Welcome.
Thanks a lot. Those are good questions that need to be asked. So next one, we can go with Amy. Yes.
Cool. Thanks. That was an awesome presentation. I just had a quick question on the symmetrical mold. It looks really interesting, and I just wondered if you know exactly how much material is saved versus a kind of conventional method.
Yeah. We save like half of the material. So the mold is around 400 kilograms of pine wood. So if we had to build 2 molds, we just use 800 of pine wood. So we just earn no, it's not earn. Just don't have to use twice more than the weight of the hull, actually.
That's cool. Thank you.
Welcome.
Yeah, I think that was my question as well about the innovation, I think, from your team. Also, I just have a comment. I think you've provided a lot of detail, and I know you had some fun with Michelle on MarineShift 360, which was fascinating. And what do you think is the biggest thing that you learned by using MarineShift 360 LCA tool?
I was really surprised to see how big was the impact of the out of shelf life carbon. I was thinking that it was not a lot as it is, and I was really surprised to see that the transport was so catastrophic. I mean, that's amazing to see that it's 40 or 100 times more polluting than all the fabrication and the life cycle of the hull. When I just saw that, I was like, oh, okay, that makes no sense to go in Italy. So Well, yeah, it's like it's a bit difficult to imagine to make an environmental impact project by traveling like 7,000 kilometers and have a so bad impact on the environment because of the transport. So I mean, that's the 2 points that surprised me the most in the Marine Shift 360 use. Sorry.
And that transport impact was shipping the moth and
shipping the
5
moth
students, right?
by plane
From
in a way, and by boat in another, and travel for the team by plane. We don't have choice.
You can always sail across the Atlantic.
We need to build another 4 moths, and they need to be really strong. You need to characterize your out-of-date pre-preg.
Sorry, I can't hear you.
You will need to build another 4 moths and be sure that your old pre-preg holds well for the trip. So thanks for that. Actually, I'm really happy with all the work. I will have a lot of questions. I think we're gonna keep those for when all the projects are finished and we see you with the boats here in Garda next year. And if Andrew has some more questions, I guess he does.
Yeah, I was just interested generally for the 3 teams that are presented, and brilliant, thank you. It's just each of you have come from a different angle, and in fact, your presentations touched on different things. But I'm really interested to know, with people who are of your age, whether this to you was an academic exercise, or was it based on something that you and your generation are feeling you've got to address for society? We had a conversation this morning where Anne-Cécile Turner was presenting, as was Blair Tuke, who was one of the world's top sailors, of course. And Anne-Cécile was talking about the importance of the changes in society. And it's your generation that are going to be, if we're going to change society, it's your generation, I think, who are going to carry that flame. Is that something you're feeling, or is that just a romantic notion from somebody of my age? And perhaps we want to start in the order of answering of the way the presentations were done. So, because we haven't heard from you guys for a little while now.
So yeah, we can start with Milano. If we wanna comment quickly on Andrew's question. They're fine. They're not muted. I think you have your microphone muted.
If I can say something. Okay. From our perspective, for sure, this project is like something that goes from the deep. Okay, I mean, our generation is meant to solve, and maybe not only ours, but the future generation are meant to solve sustainability problems. And if doing so, we solve. I mean, we make one sector, that is, for example, shipbuilding, going ahead toward this kind of objective. We will be only proud of it. I mean, but it comes from our deep. It's our duty to perform something, to create something, but sustainable.
Great,
thank you. Shall we keep on going to?
Yes, let's go with Domenico from Torino.
Yeah, you hear me clearly. I agree with what Milano said, and I think that I don't know if it's thanks to these initiatives or of its self-growing, the awareness of the problem of the planet, but this is becoming a priority for us and for our generation, I think, because there is the awareness of the problem. that we are facing, and we know that if we don't solve it, it will be really bad. So in conclusion, yes, I think that yeah, it's growing from the inside of us, that this kind of awareness.
Similar view in Canada?
Yeah, I mean, environmental problems are a priority for everyone in our generation, I think. And I mean, that's really interesting to have such project that is oriented principally on the environmental aspect. Sorry. I mean, for me, it's really a priority to save the environment. For example, I'm a mechanical engineer and I'm still studying mechanical, but half of my lessons in school treat about environmental and how to save energy, how to reduce the impact. So, I mean, that's for me, that's really a priority.
Great, and I've got a couple more if you don't mind, guys. One of them was about the materials. It was, and if the three groups can educate me a little bit more, and maybe Michelle might want to chip in there too. I was fascinated to learn about the basalt, and that made me think about something. I realised that in one of the newest SailGP teams is the Danish team, sponsored by Rockwool, and I'm pretty certain that Rockwool invested 50 million euros in a new basalt fiber creation facility. So where are we at with materials? Are these real alternatives to the drive towards carbon and the lightness and strength of carbon? Is it something we can really consider? I know obviously within the world of sailing that we still make class 40s out of glass fiber. So not every boat is being made of carbon, we've got to afford it. And we have the problem with the damaging impact of carbon. But are there going to be materials that are alternatives to carbon? It really is the question for you guys.
I think basalt is not the solution, because to make basalt fiber, you have to you need a high temperature process, which is more high than to make glass fiber. But I think we have to think about the linen fiber and all the fiber that come from plants, because they have really, really good property and can be made everywhere around the world. So those fiber could be a really good option for the avenir. But they have like problems because of their porosity and because of the water they can stock. That could be really problematic with resin. So, I mean, you have to make research and use the good resin to make a good composite material.
Yeah, so on the resin side, I think that you Canadians have probably got an unfair advantage. You probably just take maple leaf sap from the trees, don't you?
Sorry?
I was making a joke. I was just saying that you have an unfair advantage. You take maple leaf sap, you take the resin straight from the trees.
Maple syrup.
I don't know if you can build like composite material with sorry.
It's the maple leaf. I thought it was the maple leaf forever.
I don't know if syrup is able to make a composite material. Maybe yes.
Okay, so we're gonna move on with one last question. I think Laura might have one. We're gonna close with that.
Yeah, it's. I guess it will be very good to see, as Jill was saying, how you are changing your design with these specifications, but also at the end, when the boat is built and sailed, hopefully next year, if we don't have any more lockdowns, how you will kind of plan the future of SUMOF for the next students that will come, because many of you may be master students or kind of towards the end of your academic life. So how you will engage new students and in these projects, which are sometimes you don't get credits for university, but I know many of you are inspired, and yes, how you plan the future of this kind of project to follow on in the next years.
For us in Canada, it's quite easy because there is a lot of students club in the school, so there is a lot of turnover of students in the clubs. So it's really there is no chance that the club just stop, because this club is like has been built like 8 years ago and it's still running. So I mean there will be no problem to have new students that involved in the projects. And the project is really interesting also, so I'm not stressed about that.
Great to hear that.
With the enthusiasm and the great attitude, you can do great things, and that's how we are moving on. In fact, every year we recruit people. There are people that go out and people that come in. In fact, now we are on this delicate phase that is the recruitment, and we'll see how the COVID affected this. But we are optimistic, and just by telling them what do we do, they care, they enjoy, and they have great time. So I think so they stay attached to the team.
Great.
I think.
So last comment on Milano.
Yeah, we totally agree with our colleagues, and we think for sure that the recruitment is necessary, of course, each year, because as you said, we need new people because many people are going away because they graduate, etc. But also we know that this kind of challenging, like sustainable challenging, are attracting more and more people, because as I said before, as a link, as a previous question, is something that touches every of us. I mean, in the depth. So the interest is really present. So we hope to be able to collect new people inside our team also next year.
Awesome. Great to hear that from all the teams, and we really hope to have some new teams soon. We were contacted by other schools that are willing to join for 2021, and that gives us a lot of hope. Like the most we are, the better it is, in my opinion. And I don't know if you have any final comments from the jury side. We will need to move on pretty soon with Laura. Actually, Laura she will keep talking with us. We will keep torturing her. We wanted to keep torturing the students, but we can't. So
I just want to say thank you so much. This has been the most challenging time probably for any of us. You have managed to keep your designs going and did so much work over the summer without being in person, sometimes on your own, I'm sure. We appreciate the work you're doing. We're so glad that there are people like you interested in being more sustainable and supporting the whole marine industry. It's so exciting and refreshing to see your presentations, to meet you and to speak with you. And I'm just so glad and thankful that you're all safe, and just thank you. And let's hope for a great 2021 where we can see your designs. So thank you so much for your time and effort and interest. And thanks to Michelle and Amy for your time as well. I don't know if this is okay, Bruno. Michelle and Amy and I will kind of collect our thoughts on the judging and send you our comments later today. Okay.
Yes, we will announce the positions tomorrow during the forum sessions. So thank you very much. We will cut on the live right now. So thank you.
Thank you.
Thank you.
Thank you to all of you. Bye.